Okay, so now let's discuss the AWS batch. So the idea is that you can run batch jobs as Docker images, and you have two options to run them. So the first one is to run these batch jobs on Fargate container, and this gives you a fully serverless offering for running batch jobs, and it's very handy also. I have used it also myself for a few things, and you can have dynamic provisioning of the instances. It could be EC2 and Spot instances within your VPC. Uh, and we'll see this later on in some next slide in this slide. So two options for batch. Please remember them. Next, you choose the optimal quantity and type based on your volume of batch jobs and requirements. And overall, batch manages either Fargates or EC2 for you. So we consider it as a fully serverless service. You are only going to pay for the underlying resources used for Fargate or for the EC2 instances. So for example, you can do batch processes of images. You can run thousands of concurrent jobs, and you can schedule these batch jobs using for example, CloudWatch events, Event Breeze, or orchestrate them using the AWS step functions. So so let's look at a possible solution architecture for creating, for example, some thumbnails out of the images from Amazon S3. So in batch, we are going to create a batch job, and it's going to be managed by Elastic Container Service (ECS), and it could be either these two instances, Spot instances, so as of Spot Fleet, or using Fargate in the serverless fashion. So now, as a user, we want to upload files into Amazon S3. They are going to be images. Now, how do we go from Amazon S3 triggering a batch job? Well, two options. Number one, we can use the Amazon S3 event notification and trigger a Lambda function. That Lambda function can do an API call using the AWS SDK to start a batch job. Option number two is we can push an event directly from Amazon S3 into Amazon Event Breeze, because Event Breeze can directly also read these Amazon S3 event notification, and Event Breeze has a direct integration with Amazon ECS. So the benefit of this step is that you have more filtering capability as part of the Amazon Event Breeze, and you have a serverless offering because you don't need to manage any kind of code. Event Breeze knows how to invoke AWS batch. So once the batch is invoked, what's going to happen is a Docker image is going to be pulled by your batch job from the Amazon Elastic Container Registry (ECR), for example, and then your code will run. So your code may need to retrieve the file from Amazon S3 using an API call. So you need to make sure that this job has the correct IAM roles, of course. And then once the file is retrieved, it is going to be processed and sent to the target. Amazon S3 bucket versioning, Amazon S3 bucket destination, and then finally maybe we can insert some metadata in Amazon DynamoDB. So for all these things, you need to make sure that the IAM role is correct. So what is the difference between Lambda and the batch? So well, a Lambda gives you a time limit. Lambda gives you a time limit. You have limited runtimes, so you get access to the built-in runtimes, or you can get a special container Docker images built especially for a list data, but not all kind of Docker images. Lambda gives you temporary disk space, but in a limited fashion, and the Lambda is serverless, whereas batch will have no limits on no time limits. So you can have a batch job, so as long as you want, running as long as you want. You can have any runtime as long as it's packaged as any kind of Docker image. So you have more flexibility here as well. It's going to be relying on EBS or the instance store, or for disk space, or it relies on the EC2 instances that can directly managed by AWS. So, or if you want to go serverless, it relies on Fargate. AWS would rely on Fargate in case of the serverless. Now let's talk about these compute environments in detail. So the first one is managed compute environment, and in this case AWS batch will manage the capacity and the instance type. within your environment, and you can choose between on-demand or spot instances, and you can set a maximum price for the spot instances. So that means that with this, we don't need to worry too much about the capacity. It's Amazon's job to scale that capacity for us, and we hopefully get good pricing as well. So this is of a more managed alternative, and therefore it's called the managed compute environment. All the instances are going to be launched within your own VPC, so you need to make sure that if you launch your instances in your own private subnets, it needs to have access to the Elastic Container Service. And so that means either you have a NAT gateway or the NAT instance to get access to the ECS service for the public route, or you need to create a VPC endpoint for your ECS service to access it privately. Next, you have unmanaged compute environment, where you control and manage the instance configuration, provisioning, and scaling. So this is more responsibility to you, and you have to pay for your instances obviously on your own. So let's have a look into the managed compute environment in details. Okay, so because that is the important one. Okay, so what do we have? Well, we have batch, and we set how many min or max virtual CPU we want to have in our compute environment. And if you want spot instances, and for example, the spot instances will launch m5.large, c5.x large, c5.2x large, and R5.2x large, these instances. So this doesn't matter really, the type of instance that gets launched. What really matters is how many min and max virtual CPU we have set, and then we'll have our instances summed up together for the virtual CPU, and we'll see if that fits our batch managed compute environment. So then we have a batch job queue, and this is how the jobs are being distributed to our EC2 instances that will be running the Docker containers. And so to send a job to AWS batch, the one thing you have to do is to use the SDK to add a job to the job queue. And but this is something you can do with the Lambda obviously, or CloudWatch events can do this for you, or the step function can do this for you as well. And finally, in case you have many jobs in the batch job queue, you can set up auto scaling. So go through the managed compute environment to automatically create new spot instances or new on-demand instances to respond to the increase or the decrease in jobs. So you have a really good, well-fitted environment based on the size of your job queue. Finally, I said that the one batch job usually equates to one institute instance. One EC2 instance, one batch equates to one EC2 instance. That's not the case when you have multi-node mode. So this is a newer mode called multi-node, and this is a good one if you want to do large scale high performance computing HPC. And so in this case, you are going to leverage multiple EC2 or ECS instances at the same time to run your job. So it's really good when you have tightly coupled workload, and you need to have multiple instances at the same time to share the workload to process it faster. So this represents a single job, and you specify how many nodes to create for that one job. So you are going to have one main node that will manage all the other nodes, and the other nodes are going to be called child nodes. So it does not work with spot instances for now, and it works better if you are EC2 launch mode in the placement group cluster. Because you are going to get enhanced networking out of it in the cluster. So very important, multi-node does not work with the spot instances, and it is better to use a cluster mode for placement group. So we have placement group of cluster mode. That means that everything is going to be on the same rack within the same availability zone, and the batch is going to submit a multi-node job. So there's going to be one EC2 main instance that will be launched, and the EC2 instance will launch and manage other EC2 instances within your multi-node job to perform the job. and then everything will be shut down. So that's all, everything will be shut down after of the completion of the, and then everything will be shut. So that's all you need to know for the AWS patch, and hopefully that was very helpful, and I just somewhat learned some new knowledges, and so that's it. I will see you in the next lecture.